Our next goal is to simplify or work through dividing radicals. With dividing radicals, there are a couple different approaches you can go at depending on what our numbers are. But there's one approach that'll work every single time. So that's going to be our goal here. What we're going to do, or what our problem is that we have a radical in the denominator. Our radicals, square root 3, square root 5, square root 2, when they're fully simplified, those numbers are what we call irrational numbers. If you were to plug it into a calculator, it's going to spit out a crazy decimal. There's no repetition, there's no pattern to it, so it's an irrational number. I can't write it like a fraction. And that's what we want to undo here, is we don't want an irrational number in the denominator. So our goal, or what we're going to be doing, it's called rationalize the denominator. To rationalize the denominator, what that means is I just want to get the square root out of the denominator. I want the denominator to be a nice, pretty number, which we call an integer, a whole number. Okay? So what we're going to do that is we know that if I multiply a radical by itself, so if I take the square root of 5 and I multiply it by the square root of 5, that's going to get rid of that radical for me. But if I multiply to the denominator, I have to multiply to the numerator as well. So what happens when I do this, I get the square root of 3 times the square root of 5, which is the square root of 15. And then the square root of 5 times the square root of 5 is 5. So now my denominator is an integer. So here, this 5, an integer, again, is a whole number. We have now taken our irrational number and we've rationalized it. 5 is a rational number. So that's all. That's my solution. Boom. I don't want the radical in the denominator. It's no longer there. I'm good to go. Similar problem here. I have a root 3 in the denominator. Yes, there's also a 3 out front. That doesn't matter. I still just want to get rid of the radical in the denominator. So I'm going to multiply it by itself. Root 3 times root 3. If I do it to the denominator, I need to do it to the numerator as well. So here I have 2 root 2 times root 3. So that's going to give me 2 root 6 all over. And then 3 root 3 times root 3. Those become just 3. 3 times 3 is 9. Rationalize the denominator. Done. That's all it is. It's not too bad. We might have to simplify. Always check to see if we simplify. But our goal is to rationalize the denominator. And really what we're doing there is we multiply the radical by itself. All right. So here with this example, we're probably going to have to do some reducing here. I can kind of see it already. But what I want to do, I want to get rid of the root 6. So I'm going to multiply it by itself. So the square root of 6 divided by the square root of 6. All we're doing here is multiplying by a fancy number 1. Root 6 divided by root 6 is 1, so we're not really changing our expression. That's the beauty of it. Here in the numerator, we have a plus sign. So I'm going to distribute that root 6. So that's going to give me 2 root 6 plus 3 root 12 all over 6. My 2 root 6 is fully simplified. I can't do anything there. The only factors of 6 are 3 and 2. So we'll leave that. Here with the 12, the factors are 4 and 3. Square root of 4 is 2. So I'm going to take 2 times 3, and that's going to become 6 root 3 all over 6. So now my denominator is a rational number, and I have simplified my radicals. The cool thing here, 2, 6, and 6 are all divisible by 2. So what I'm going to do is I'm going to factor a 2 out. So I get root 6 plus 3 root 3 all over 2 times 3. So these 2's are going to reduce. So my fully simplified answer is root 6 plus 3 root 3 over 3. So that one's a little bit more complex. There's a little bit more to it, but the process itself isn't that intense. So I've got one more that I want to talk about, which is this problem here. With this example, the addition is in the numerator. That wasn't an issue. We just had to distribute in the numerator. But here in the denominator, if we were to just multiply by our square root of 2, I'm going to end up with a 2 root 2 in the denominator again. So we have to change this one up a little bit. So what we're going to do with this guy is we are actually going to multiply by the conjugate. Conjugate's kind of a new word for us. We probably haven't heard that before. But what we're doing, because this is 2 plus the square root of 2, its conjugate is going to be 2 minus the square root of 2. This one's plus, this one's minus. Together they make a conjugate pair. The cool thing is they behave in a way that's going to help us get rid of this radical. That's the whole point. So conjugates, when we think about a conjugate pair, this one's a plus b, so its conjugate is a minus b. But if we have a minus b, its conjugate is a plus b. Okay? So what I'm going to do is I'm going to multiply by my conjugate here. We're going to see some distribution, so we've got to take care of that, and then we're just going to simplify, see what happens. So in the numerator, I'm going to distribute my root 3. So I'm going to get 2 root 3 minus the square root of 6. In the denominator, I have 2 times 2, which is 4. 2 times negative root 2, which is negative 2 root 2. 2 times root 2. And the square root of 2 times negative square root 2, which is negative 2. Square root of 2 times square root of 2 is 2. Positive times a negative is negative. So now I'm just simplifying here. My numerator is fully simplified. That's good. And then in my denominator, negative 2 root 2 plus 2 root 2, if I were to add those together, that equals 0. And that's what the point of the conjugate is. It's going to make these middle terms 0. So there goes the radicals in my denominator. And then I'm left with 4 minus 2 over 2. Okay? So again, just recognizing that conjugate, it's more of a complex idea, but I just wanted you to see it because we're going to be using it. Good luck with your practice.